Hello, everyone. I hope all you guys are doing well, and I'm sorry that we have to be doing school like this right now this week. It is what it is, and hopefully I'm able to come back in person to see you guys or to meet you for the first time next week. So let's go ahead and get started. We are going to start a new unit right now, and it's a little weird, but we're going to start actually in 8.3 today instead of 8.1. Okay, and there's a reason for that that we'll go over once we get deeper into this. But yeah, for right now, we're starting in 8.3, which means your assignment that you're doing today is 8.3. And don't do 8.1 because it won't make any sense because we haven't talked about anything in 8.1 just yet. Okay. All right, so let's go ahead and get into it. What we're going to focus on in this lesson is solving what's called an exponential equation, okay? So take a look at this for just a second. We're attempting right now to figure out what x is. So what is the value for x? What does x equal in this equation, okay? So take a second, look at it, think about it. What strategy are you using to think about how to solve this, okay? So probably, potentially, what some of you guys would be thinking is let's just plug numbers in and test out what x is. So I'm just going to do a guess and check. So maybe if I test this and I start just plugging in numbers for x. So right now I'm just guessing, okay? So really I'm just going to do a guess, okay? So maybe you guessed like that x equals 4. So we can try out that guess, plug that in, see does 2 to the power of 4, does that equal 64? So let's check that right now and see. No, not quite. That would make 16, not 64. So it needs to be a bigger number. So maybe we can try like 6 and see if that works. So 2 to the power of 6 and see what that makes. And yes, indeed, that does make 64. So after guessing a little bit, we end up getting our answer for this. So that's one strategy that we can use, and it's actually a really good strategy to use when you're taking a test and you don't really know what to do for a problem, is to do this strategy where you just guess and then check your answer, okay? So that's the value of x. X equaled 6, okay? So what we're really going to be learning here, okay, rather than just guessing, is what method can I use when I get harder problems, okay? This problem, it's really easy. I can just guess it through. But if I get something a little bit trickier, what's the math behind this that's going to help me solve harder problems, okay? So the math that we're going to be using, or this strategy for today, is we're actually going to rewrite this problem so that there's the same base on both sides of the equation. Okay, so if you don't know what a base is, this number right here, that would be our base, okay? This value right now, it's an x, would be our exponent, okay? We know what an exponent is. So whatever your exponent is like branching off of, that's the number that we're going to call the base, okay? So the base, it's there, and the exponent comes off of it, okay? So we need to get the same base on both sides of our equation. Right now, this has a base of 2. This has a base, so this is the base over here, of 64. Can you guess what the exponent is? Because this does have an exponent, just like this does on the other side. So if you're thinking that the exponent is 1, you're correct, okay? So both of these, on both sides, they have a base and they have an exponent, okay? So our goal, how do we rewrite this so that there's the same base? So we have the same base on both sides. So to do that, the trick that we're gonna learn is you're gonna take the bigger base, okay, which is 64, and rewrite it into the smaller base, okay? So let's do that right now. So I take 64 and I rewrite it as 2. So it's the same base that I have on the other side, okay? So my exponent on the left side is going to stay the same. I didn't do anything to the left side, but on the right side, because I'm rewriting the 64 as a 2, I need to make sure that this is still equal to 64. So that's where my exponent of 6 is going to come in, okay? So, and we just tested this a second ago, and you can plug this in right now into your calculator just to doubly make sure, but this value right here, this is 64, right? 2 to the power of 6 is 64. So we rewrote this. We didn't change the value because it's still 64 on the right side of the equation. But now, because there's the same base on both sides, now I get to use this trick where I get to completely cross out the bases, and I'm left with the exponents. So I get the exponents equal to each other, and then that would be my answer. Okay, so this will make a little bit more sense once we try some more problems with this, but that's the whole goal of today, is how do we rewrite a problem so that it has the same base on both sides, and then I can just cross out the bases completely. All right, so let's try another problem. So this example over here, again, we're going to solve for x. A little bit trickier here to kind of guess our way through, but we could try guessing a little bit. But let's go ahead and try using those strategies that we talked about just a second ago with the bell work, okay? So we want to rewrite this so that there's the same base. Okay, so rewrite the problem, so that's step one, so that you have the same base on both sides of the equation, okay? So we have two different strategies here, and one of them I just used a second ago, which was we rewrote the bigger base and we changed it into the smaller base, okay? So let's see if we can use that same strategy here. So 4, I keep that exactly the same. 3x, I don't change anything on the left side. But now I'm going to see if I can rewrite 8, so it has a base of 4. Okay? So I'm thinking right now to myself, I want to keep this value so that it's still 8. Okay? So at the end of this, whatever I get over here should still be equal to 8. So let's see if we can kind of guess out an exponent that would still make this equal to 8. So maybe like 4 to the power of 2. Does 4 to the power of 2, does that still equal 8? So let's check and make sure. Well, some of you off the top of your head hopefully know that. That would be 16, right? 4 to the power of 2 is 16, and it's not 8. So that is not equal. So it won't work to rewrite it this way. It has to be equal to that number. Okay, so that doesn't work. Does 3 work? No, that would be a bigger number. Does 1 work then? So if we try 1, right? A smaller number. No, that's still going to be equal to 4. And it's not becoming 8. So 8 isn't working right now. So strategy 1 is failing us. We can't rewrite the bigger base to become the smaller base. So 4 is not working. Okay. So now here's where we would use our other strategy. So strategy 2, if the first one doesn't work, we're going to try to rewrite both, okay, of the bases to be an even smaller base. Okay, so now both of the bases need to change. So let's go back, erase this a little bit. Okay, and now I have to think about how do I rewrite both of those bases so they're an even smaller number, okay? So one number that you think that they probably have in common that's even smaller, hopefully you're thinking 2, okay? Because they're both divisible by 2, okay? So when you're thinking about that even smaller number, make sure it's a number that both of these numbers are divisible by, okay? So let's rewrite this so it has a base of 2, and 8 so it has a base of 2 as well, okay? So how do I rewrite 4 so it has a base of 2, okay? So if you're thinking that I would take this and make the exponent 2, that would be correct, right? 2 to the power of 2, that does equal 4. So that's true. And then here, how do I rewrite 8 so it has a base of 2? So it would have a different exponent. It's not going to be 2. So if you're thinking 3, that would be correct. So that would be equal to 8. So I rewrote 4. This is still 4 here. So this value I just boxed in blue, it's still the number 4, okay? It just looks a little bit different, so it helps me solve the problem. And this is still 8. It just looks different, so again, it'll help me solve the problem, okay? So this is still 4, and this is still 8. So now that I've done that, okay, and I've rewritten 4 and I've rewritten 8, I have to worry about the rest of my equation here, okay? So this part that I've circled in red, that was the only thing that's changed here, but notice this 3x was still there, and we haven't factored that in to our problem yet. So we're just gonna drop that down. It's still gonna be in the exponent spot, but I'm going to make sure I have parentheses around it. Okay, so I'll have 2 to the power of 2 multiplied by 3x. Okay, I'll bring down the equal sign, and the same thing here, my exponent is still going to be in the exponent spot, but I really need to make sure that I have parentheses around this as well. Okay, so that's our whole equation. We rewrote 4 and we rewrote 8, so now it looks like this. And because we've done that, we can use our trick here, which is once the bases are the same, we can cross them out and set the exponents equal to each other. Okay, so cross out the bases, perfect, they're gone. And now I set the exponents equal. Let's go ahead and actually multiply these two when we get to the next step. So 2 times 3x is just going to make 6x. So that part in blue changes to 6x. And then this part over here, I need to make sure I'm taking the 3 and distributing it. So I multiply it to the x and also to the 1. Okay, so 3 times x, I get 3x. 3 times 1, I get positive 3. Okay. All right, so now I'm here, and this hopefully should be pretty smooth sailing from there because we've practiced solving equations like this last semester. So we just solve this now, then for x, okay? So if I'm doing this, I look at both sides of my equation, make sure they're simplified. They are. And then I look at whatever has the smaller x value, which is this side, and I want to get rid of the little guy. Okay, so I need to do the opposite of 3x. So subtract 3x from both sides. So again, I'm picking on the little guy. I pick on the smaller x value. I do the opposite of that to get rid of it. On this side, okay, I end up getting 3x. So that's gone over here. I bring down the 3. And then here, the 3 and the x are being multiplied. So the opposite of multiplication is division. So I have to divide both sides by 3. Okay, so perfect, that gets the 3 to cross out, and now my value for x is just 3 divided by 3, which is equal to 1. Okay, so that's how I would solve for x, okay? And maybe you could get there through guessing a little bit through this problem, but those are our strategies if it gets a little bit too hard to guess on a problem, okay? So we're gonna slowly ramp up our problems a little bit. I encourage you to take a second, pause this video, and try out 1 and 2 on your own. Okay, and then unpause it when you feel like you have an answer so you can check and see, okay? All right, so let's jump into number 1. So this one, we see that the base on both sides, so we have a base of 4 on one side and a base of 2 on the other side, okay? So we'll try strategy 1 first. So we're gonna rewrite the bigger base to be the smaller base. So if I'm gonna rewrite 4, so it has a base of 2, okay? So now I have to think what the exponent would be. So if you're thinking 2, that's awesome because then 4 is going to be equal to 2 to the power of 2. Okay, so I got something that's true, that's equal, and I can continue on my way. Okay, so nothing on the other side changed. So now they have the same base. So 4, I rewrote that, so it's 2 to the power of 2. Notice it still had an exponent there, so I'm going to bring that down to the next line in parentheses. So again, make sure it's in parentheses. And there we go, perfect. Both bases are the same. I can cross them out. And now I end up in kind of a weird spot, but maybe some of you guys were able to see this because notice over here, there is an exponent on the right side, right? Just like in the bell work, if I don't see an exponent, the exponent is always 1. Okay, so this does have an exponent of 1. So when I cross out those bases, I should get, and let's go ahead and multiply this together. So 2 times 2x, that's going to give me 4x, is equal to 1. So I'm just left with the exponents. And then, because these are being multiplied, I have to divide by 4. So I end up getting x equals 1/4 as my answer. So one thing I want to talk about really quick before we move on to the next problem is when you're doing these problems, and if you're not sure if you're doing them correctly, there's always a way to check your answer by plugging it back in. So you can always check your answer. All you have to do is plug your answer back into the problem and see if it makes a true statement or not, okay? All right, let's go ahead and do this last problem here, and then we'll move on to a couple harder ones. Okay, so this one, here my base is 10 and 100. So let's try strategy 1. We can rewrite the bigger base to become the smaller base. So bigger base here, let's see if I can rewrite this so it becomes 10. Okay, so if I write 10 to the power of 2, okay, that is going to equal 100. Okay, so 10 to the power of 2 is equal to 100. That's how I can rewrite it. And everything else about this is going to stay the same. So this still has a base of 10 on the other side. And now I can just bring down the exponents. So I bring down this 3x, it's still there. Bring down the 2x minus 7. And again, really make sure those are in parentheses, and your answer should look like that so far. Now that the bases are the same, I can cross them out. And I have the exponents equal to each other. So I just get 3x is equal. Make sure we distribute the 2 to 4x minus 14. Okay. All right, so now I just have to solve this equation. And similar to this one up here, I again want to make sure I pick on the little guy. It's kind of a weird phrase, but it helps you remember what to do when you get to this point in your equation. So pick on the little guy. So out of my x values, I pick on the smaller one, which is 3x, and I need to do the opposite of that. So I'm going to subtract 3x from both sides, okay? So when I do that, it cancels out here, which is a little weird, I know, because now we have nothing left on this side. So when we did this, the only thing that's actually there that's left is kind of just like a placeholder is 0, right? Because that cancels out, there's nothing left, so I have 0 on that side. Over here, I just end up with 1x, and you don't have to write the 1, but we can have that in there if you like. So we have 1x minus 14. And then now, just to get x alone, I have to deal with anything that's being added or subtracted, so I have to add 14. So I'm doing the opposite of that to both sides. Okay, so let me go back up here and rewrite this. So now I get 14 on the left side is equal to 1x. I don't need to write the 1 there, but my x value is now 14. So that should be your answer to this problem. Okay, so let's go ahead and move into some trickier problems that are still using this concept, but you're just going to see them on top of some other exponent rules, okay, that we've talked about in the past. So some previous rules that have come back are going to come back from semester 1, okay? So we're going to look at two different types of problems. So one where we're simplifying, and the other where we're solving for x, okay? So in this problem, in order to simplify this, okay, we have to, again, make sure that both of the bases are the same, okay? So make both bases the same. And again, we're doing this using one of those two strategies. So let's, again, always start with strategy 1. So let's rewrite the bigger base to become the smaller base. Okay, so here's the bigger base, 27. Let's see if I can rewrite this as 9, okay? So let's think to ourselves. So 9 to the power of 2, does that equal 27? No, that's going to make 81. And if I do even a bigger exponent, it's still going to be bigger than 27. 1 isn't going to work, so I can't use strategy 1. Strategy 1 isn't working. I can't rewrite the bigger base to become the smaller base. So that's not working. So 9 as a base didn't work, okay? So now I'm going to try strategy 2, kind of just like with this problem up here, and I'm going to see if I can rewrite both of the bases to be an even smaller base, okay? So think of a number that both of these numbers are divisible by. So 9 and 27 are both divisible by 3, okay? So let's try 3 as our even smaller base and see if that works. So let's rewrite 9 as a base of 3 and 27 as a base of 3. All right, so 3 to the power of 2, that's going to equal 9. So that's a great way to rewrite that. And 3 to the power of 3 is going to make 27, okay? So whenever you think of your base, you're just trying to figure out what's the exponent going to be that will make it equal to that base there, okay? So now 3 over 2 is equal to 9. 3 to the power of 3 is equal to 27. And let's go ahead and add in those other exponents that were already there. So 4x was already there, and negative x. Okay, so now that I've done this, this one, you might be really tempted to cross out the bases, okay? So here we don't cross out the bases. So don't do it here. And the reason is because this problem here is simplifying. These ones we were solving, okay? So we were trying to figure out what x equals. All of these problems, that's our goal. What does x equal in all of these, okay? Here, we don't care what x equals. So what x equals doesn't matter to us at all. Okay, we're just trying to simplify this and reduce it down so it's the smallest possible expression, but we don't care what x is here, okay? So in order to do that, we're going to use one of the rules from last semester, which is if you have something like this, where they're both the same base, and there's division, okay, so I have this divided by this, I can take the exponents and subtract them. Okay, so that's a rule that we learned from last semester. So maybe with something like this, it'll make a little more sense. So here's a quick little example. But something like this, we learned if it has the same base, we take the exponents and subtract. So then this turns into x to the power of 1. Okay, I just do 4 minus 3. So we're using that same rule over here. Okay, even though the bases are numbers instead of x's, the same rule still works. Okay. So let's go ahead and simplify this just a little bit. So I'm going to rewrite it over here, and I'll multiply those exponents together. So I get 3 to the power of 8x all over 3 to the power of negative 3x. All right, so right now I want to do exactly what I did over here. So I'm going to subtract the exponents. So subtract exponents, but don't cross out the base, okay? So this is still going to have a base of 3, and I'm going to do 8x. So whatever the numerator is goes first, because the order you multiply things in really matters for this problem, so make sure it has to be 8x first, so whatever the numerator is, minus the denominator. And notice the denominator is negative, so this is going to be 8x minus negative 3x, okay? So 8x minus negative 3x, which we know a negative and a negative make a positive, okay? So really I'm just doing 8x plus 3x, which is going to give me, well, 11x. So I get 3 to the power of 11x. And that would be my simplified answer when I'm done, okay? All right, this next problem, we're now, instead of simplifying, we do want to solve for x, okay? So we do want to figure out what x equals, so that is the goal here, okay? So in order to do it over here, we are going to have to use some of the strategies that we just practiced in simplifying, okay? So in this problem, just like we've been practicing, we want to see if we can make these bases the same, all right? And I'm focusing on the 16 here because I know that this can become a base of 4, okay? So I can rewrite this problem like this. So let me keep the base in this color. And again, I'm just using strategy 1. I want to rewrite the bigger base to become a smaller base. So if I can rewrite 16 so it has a base of 4, that'd be 16 changes into 4 to the power of 2. Okay, so perfect. That's still 16. That looks great. And at this point, it's really similar to the problems that we did up here, but we don't cross out the bases yet for this problem, okay? We can only cross out the base if we take this 4x squared and we have to move it up to the numerator. So move to the numerator. Then we can cross out the bases. Okay, so take a second, think about how we would move this up to the numerator. So if you're thinking that you would do this, okay, so 4 to the power of 2, if I want to move it up to the numerator, the exponent has to change signs, okay? So this is going to be rewritten as 4 to the power of -2, okay? So I moved it up to the numerator, that placeholder of 1, I don't have to write it there anymore, and now I get this, so it's not a fraction anymore, okay? And the exponent just changes signs. So let's go ahead, cross out the bases, and now we can easily solve for this. And we get x equals -2/5. Okay, once we just divide by 5. So that would be my answer for this when I'm solving. Okay, so your job now, now that we've gone through these two examples, is to, again, take a second, look at these next two on your own, pause the video, and see if you can figure out how to do these before I go over them, okay? All right, so this problem here, we're simplifying, so I do not want to figure out what x equals. That is not the goal here. I just want to reduce this down and make it as small as possible by making all the bases the same. So here's a base, here's a base, here's another base, okay? So we're going to try to rewrite this 9 so it has a base of 3, okay? So we're rewriting the bigger base into a smaller base. So I can change this 9 into 3 to the power of 2, okay? That x is still there. And then I'm going to keep everything else the same because 9 was the only base that I changed. Okay, so I'll just keep this as 3 to the power of 6x, and then times 3. Okay, so all my bases are the same. Wonderful, okay? Again, be careful, don't cross this out, okay? You can only cross out the bases when I'm solving. So these problems on the right. Okay, so here, now we're going back to another rule that says if I'm multiplying, okay? So here, this term, and this term are all being multiplied together. And it's written, so it looks like different things are happening to them, but truly, all of them are just being multiplied together. So I could rewrite it even like this. I don't even need the parentheses because I think they're just kind of there to confuse you. But there we can rewrite it so everything's being multiplied. You just need to understand when you see parentheses or that dot symbol, either way, if it's like that or if it's right next to something in parentheses, it's being multiplied, okay? So 3 different ways that you can see multiplication, okay? All right, so the rule is if everything is being multiplied, I have to take all of my exponents and add them together, okay? So this exponent, and also this exponent of 1, I have to add all of those together, okay? So I combine this all, just like I did over here. I had these 2 different terms, these 2 different 3's, and I combined that to be 1 3. So all of these terms are going to combine into 1 3. With us adding all of those exponents together. So 2x plus 6x, I get 8x, plus 1, I just get that plus 1 at the end, because the 1 and the 8x can't combine together because they're not like terms, okay? So I get 8x plus 1. And that would be my final answer. So I simplified it down as much as I possibly could. Okay, last one over here, which is kind of, again, using some rules from this one that we just looked at. But if I have all the bases that are the same, and here I don't have to do any rewriting like we've been practicing, so they're all just a base of y, I can go ahead and add the exponents together because all of these terms, so this, and this, they're all being multiplied together. So since they're all being multiplied, I take all of them, rewrite that as 1y, and the exponents are all going to be added together, okay? So let's do just the numbers, the constants. So 3 plus -5 is going to make -2 plus x. Well, x, 2, they're not like terms, just like 8x and 1 aren't like terms. They both don't have an x. So here, I'm just going to tack it on to the end, and they can't combine, okay? So we'll just add all together. They're not like terms. They don't combine. Okay, so same base. Even if they're not numbers, y and y, they're the same base, so I can cross them out. And now I'm left with -2 plus x equals, and if you're thinking 1, that is correct, because this, since I don't have an exponent, my exponent would be 1, okay? Solve for that, and I end up adding 2 to both sides. To get x alone, I have to add 2. And I get x equals 3 as my final answer. Okay, so there is all of 8.3, a couple problems to practice on. So your job right now is to go through your assignment in 8.3. So again, don't start on 8.1 or you're going to get really confused. And then we'll go over the next lesson tomorrow. So check back in Google Classroom and you'll see a new video posted for the next lesson. All right, guys, bye.